In this CSEC video, we look at the three states of matter and how we can distinguish among them. By now, we should have an idea that matter is divided into three states: a solid, a liquid, and a gas. As mentioned in the previous video, these three states are temperature dependent. In other words, increasing or decreasing the temperature of any one of these states will take them from one form into another. For example, everyone knows that water exists in three states or three phases: ice, the solid; water, the liquid; and steam, the gas. If water is at room temperature and the temperature steadily increases, let's say by a stove, a microwave, or even outside in the sun, this is known as boiling, which is usually around 100 degrees Celsius for pure water. After several minutes or even hours, depending on the heating method that is being applied, some of the liquid has been constantly converting into a gas or steam above the water. In a separate but related process, when water is inside a freezer, the temperature of water gradually decreases until ice is formed. Please note that there are other factors such as the pressure above the different states that contribute to one changing into the other, but for the purpose of this course, they are omitted. Fun fact: water is the only matter or compound that exists independently in all three phases or states at room temperature at the same time. In other words, ice, water, and steam could be aligned beside each other in separate containers all at once. With that said, let us move on to how the particles are arranged in each phase. The behavior of particles in matter are very different in the three phases. The particles for each specific phase has a constant behavioral pattern. However, water in the form of ice breaks that pattern, but we'll get to that a little later. Let us briefly look at the properties of these particles individually for each phase. First up is the solid phase. Typically, or on average, the particles in a solid phase are very close together or tightly packed. They formed a well-ordered arrangement in a regular pattern. Their only movement is vibration at room temperature. This is why we expect all solid objects within the home to be at a standstill and do not move on their own. Another property, feature, or characteristic of the solid phase is that solid particles have very strong bonds or attraction between them, which is why it is so difficult to break them apart. Earlier we mentioned a feature of solid particles is that they are tightly packed. Now, a measure of how tightly packed particles are in a given matter or object is called density, and based on this definition, the solid phase is highly dense. To have a better understanding of what density is, or the most basic idea of what density is, let us use football for an example. A football stadium is well ordered, where you have the seats arranged in such a way that it follows a specific number system. Now you have a very high profile match, let's say between Manchester United and Real Madrid in the UEFA Champions League final. The tickets are sold out. The maximum seating capacity for the stadium is 100,000. On the day of the final, the stadium is full. Instead of saying the stadium is full, we could say the stadium is highly dense with fans. Also remember that these fans are seated in a very ordered manner. When an object or matter is in the solid phase, we can safely assume that no air can pass between the particles, and that is why an object as small and light as a needle sinks in water, because although very small, it is very dense. But there are some solid that do not follow this trend. For example, wood, which is still a solid, the particles are not well ordered due to kinks and distortions, and also the ability to trap air, therefore would float. Another property of a solid is its volume. The volume of solid particles are fixed, meaning its volume does not increase nor decrease, it will stay the same. Particles in a solid are very strongly bonded and their shape is constant or ordered as outlined earlier. Because of this property, solids are non-compressible. In other words, they cannot be flattened, squeezed, or pressed together because the particles are already together. Finally, of the three phases, the solid phase has the lowest or the least amount of kinetic energy, which is the energy associated with movements, and the greatest amount of potential energy, which is the energy associated with being still. Thanks for watching, and see you soon.